Alright, what we're going to look at now is we're going to look at parallel slopes and perpendicular slopes. If we look at our problem here, what the problem is going to be talking about is the line y equals 2x plus 3. So I'm going to put the line y equals 2x plus 3 into Desmos. And I can see that it looks a little bit like this. So it's got a y-intercept of 3, and it increases up 2 over 1. That's how we get our slope. Now, if we look at what the problem's asking us, it's saying to write an equation for the line that contains the point 2, 3. So, and we want it to be parallel to the line y equals 2x plus 3. So if we look back at Desmos here, this is the point 2, 3, this green point here. We want a line that's going to be parallel to that purple line and also go through that point there. If we look at it, it's got to be increasing by the same slope. It's got to go up by the same rate. So if I just take a quick peek at it, see how those are increasing at the same rate, the same slope? So that's going to be my equation. Now we're going to see how we found it. What we're going to do, since we have parallel lines, we know that this slope is going to be the same. So the line that we're looking for has to have a slope of 2, because it's going to be parallel to this line. Now, the rest of the stuff I have to find out about the line, I've got to use that point 2, 3. So if I look, my generic equation for slope-intercept form is y equals mx plus b. I know my m has to be a 2, so I plug it in for m here, which means I only have one thing left to solve for, and that is this b here. So what I'm going to do is I'm going to plug in my points x and y. X is 2, y is 3. So I'm going to plug in, we'll do it in a different color. I'm going to plug in 2 here for x. And I'm going to plug in 3 over here for y. And now the rest of this equation I'm going to keep the same. I still have my slope of 2, and I still have my y-intercept. Now, my 3, I'm going to keep the same, so I'm going to bring this right over to here. So I'm going to have 3 is equal to 2 times 2, which is 4, plus b. So now it's a one-step equation to solve for b. I want to get this b over here by itself on this side of the equation. To get that b by itself, I have to get rid of this plus 4, so I can subtract 4. Subtract 4, I'm going to find that b is equal to negative 1. So the equation that I'm looking for, that is parallel to this line y equals 2x plus 3, is going to be y equals 2x and minus 1. Because my slope was a 2, and my y-intercept I found to be a 1. And now if I jump over to Desmos to look at that to make sure it makes sense, I can see when I put this equation in, the red line is the equation we just found. The purple line was our original equation. And we can see no matter how far I zoom back here, those two lines are never going to intersect. That's because they have the same slope. Now, the tougher part is when we are asked to find the line of something that is perpendicular to a line. So parallel means they have the same slope. Perpendicular means we've got to find the opposite reciprocal. And reciprocal just means we're going to flip our slope. So right now, this line has a slope of 2. And I'm going to write that as 2 over 1. If I flip that, that now becomes 1/2. And then the last thing I have to do is also make it negative. So I have to find the opposite reciprocal, which means I change the sign and I flip the fraction. So my new slope, or my slope of a line that is perpendicular, is going to be negative 1 over 2. And if we just check that on Desmos real quick, I'm going to make this pop up. We can see here that blue line is definitely perpendicular with both of those lines. It is meeting at a at a 90-degree angle. So we know that we're on to the right track. Now, since we know that we have the right slope, let's plug it into our equation. Y equals mx. So my m is negative 1/2. Got my x here, and then my plus b. Again, I've got to plug in my point 2 for x. So I'm going to plug in 2 here. And I've got to plug in my point 3 for y. So I'm going to plug in a 3 here. All I did was replace those variables with those numbers. The rest of the equation stays the same. Now, just like last time, we have a one-step equation. We've got to simplify here. Negative 1/2 times 2. Remember, I always have this as 2 over 1. Negative 1 times 2 is negative 2. So I have a negative 2 on top, positive 2 on the bottom. We can see those are going to simplify to be a negative 1. 3 stays the same, and our b is still there. So if I rewrite this off to the side, I'm going to have 3 is equal to negative 1 plus b. Now remember, the last thing I'm looking for is to solve for this b, get this y-intercept alone. To do that, I have to get rid of a minus 1, so I can add 1 to both sides. Those cancel out, and my b value is equal to 4. So I have a b value, and I have a slope. Therefore, I can write a linear equation. Y equals m, which is negative 1/2, times x plus b, which is my 4. So that's going to be the equation that I'm going to use. Y equals negative 1x plus 4. And now if we look at this, remember the original equation said, find two lines. One of them needs to be parallel to this original line. Remember, our purple line was our original line. We started here. And we said we want a line that's parallel to that line that goes through this green point. And so we created y equals 2x minus 1. And we could see that that's parallel. Then it said find one that's perpendicular, and it goes through the same point. So we created this function here. So all we're doing is we're finding the slope by recognizing, is it parallel or is it perpendicular, and then we're finding the y-intercept by plugging in the values of those points.